Hey, Pam. How are you? Oh, yeah. Not getting audio. Ugh. Audio is all screwed up. It's working. Audio. Let's see. Say something? I'm not. Hang on, I'll just check my audio. It's playing. I'll just play a song. Okay, so my audio is working.
Is it better?
Yeah.
Yeah. Sorry. Yeah, I disconnected my computer to go to a coffee shop. Every time you reconnect, the whole thing falls apart. How are you
So
doing?
you've got a super duper laptop?
This is just my work laptop. It's the MacBook Pro 14,
Oh,
one
okay.
of the new ones.
Yeah. Oh, nice.
It's not fully loaded, but it's okay.
Yeah, so Rob probably won't be joining us. It's his brother's funeral today. I'll be attending virtually. Oh, that's fine. It's like, we've known this is coming for 15 years. He had Parkinson's, so it was a very slow process.
Okay,
but,
okay.
Yeah.
Oh,
I do want to chat to you, though. Sorry,
I didn't know you could do virtual funerals yet.
Oh, yes. No, they've been around for a while. I went to my, I've been to several funerals online. During COVID, it was just impossible to have a funeral.
Yeah.
Yeah, so they kind of worked out a protocol. Yeah, so while I've got you for a couple of minutes, did you have a look at the thing I put in Git? It doesn't matter if you didn't. I'm happy to go through it with you.
Yeah, I just joined the repo, and I just looked very quickly through it, but I haven't played around with it yet.
So I'm not defending it in any sense. I'm just seeing if I could plug his data into an autoencoder of any kind just to see if we'll even like converge. Yeah.
Mm-hmm.
So, and it does. Interestingly, it depends which columns it selects. So some of the columns don't. They immediately go to not a number. And some of them do. So do you have any way of characterizing that kind of behavior? Like, have you ever seen a situation where one set of data has vanishing gradients and another set of data doesn't?
Yeah, I think it could happen often. I guess it depends on the range and lots of different things. I don't know if, I've talked to several people, like including Robin, who like he had the same problem trying to train an autoencoder at some point. But it's just a matter of, I think, tweaking the gradients, the learning rate, and all that stuff. I don't think it's anything fundamental as far as I know, unless you have actually NANs in your data and you don't know. But if that's not the case,
I do, but I zeroed them all out. So there's a function in NumPy which will turn all your nans to zeros. So let me just share with you my screen and explain this to you. Okay. So I'm using Lightning. Have you tried Lightning yet?
Yeah, I tried it back when it started, but I mean, at the time they weren't sure that whether it's going to be free forever or it's going to be paid, so I just stayed away from it. Also, they keep breaking their API interfaces. It's not backward compatible every time they make a new change. So yeah, I just usually stay with PyTorch, just the normal version. Yeah, native. But yeah, I mean, I've seen like it makes things a lot easier. So it's a good thing.
So I've been trying to learn how to use it. It's really easy. You basically just implement some APIs. Okay, so this loads, and this is the fill the non-numbers with 0. So we now have our data frame. It's exactly the same file I sent you. This is the Lightning autoencoder example. It's just MNIST 28 by 28, and it just trains an autoencoder. Like they're not saying it's doing anything useful. They're just saying, if you wanted to implement an autoencoder, this is how you do it. So it's very, very obvious what's going on here. You set up your input and you set up your layers, and then you set up your output and you set up your layers, and that defines your encoder and your decoder. You then
sorry, so this looks to be, so this is made for MNIST because of the 28 by 28. Did you like try to play around to make it match your data set?
could do. Once again, I was just trying to touch the ground here and just see if I could even get it to work at all. So my goal was very, very basic. All right, and then so I wrote something called a lightning data loader, which is a torch data set, which you can just hand into something and it'll pull the data out you want. So I built that, and I just cached a bunch of samples of the data set in memory. I don't know whether I should have written it so that it'll generate them on demand or whether it does it ahead, but I decided to generate them ahead. And so if you load up MNIST and look at some images, they look like that. And then if you load up my data set or our data set and render it as a set of images, they kind of look like this. They're 28 by 28 images, you know, should work. Sorry,
how did you make the data 28 by 28? Isn't it?
Okay.
How do you just pick 28?
So first of all, variables? I just randomly picked 28 columns.
Okay, and then you pick 28 samples out of it.
And then I pick a start point, and I just take the consecutive time series of 28 samples.
Gotcha. Okay.
So they're like little time slices across 28 of the columns. Once again, I'm not trying to prove anything here. I'm just
no, I get it.
I'm just trying to start the inductive loop with something. And what I found was that depending on the 28 columns randomly sampled, it actually converges quite nicely. So it can actually converge on something. So there's something in there that an autoencoder can encode.
Okay.
Yeah. So what this is not doing is any form of convolution, as I understand it, right? These aren't convolutional layers. These are just
just fully connected. Yeah. Well, no, sequential, you can still make your convolution. Sequential, it just means you have it's not recurrent, right? So it just goes one after another. So linear is the one that you would want to change if you want to make it convolution.
Which I don't.
Yeah, so we don't want to do that. It's not an image. So.
No. So so this 28 by 28 is completely rubbish. Like I could change that to anything I might want to. And my question to you, or to the world in general, is what should we put in there? Should we put the entire data set, or should we put fragments of the data set starting at different times? Should we do different?
Yeah, I think it's more of a Rob question, but I would imagine, like, if you want to predict liquidity in time t+1, you probably don't need the entire history of data up until that point. So you would want some kind of a window, maybe a week, 2 weeks. I don't know what the right answer is, but I guess it's a domain question, right? How much of the previous time steps do you need to predict the next one, right?
So when I hear you loud and clear, I understand everything you said. According to Rob, at least, we're trying to write a classifier, not a predictor.
Okay, so you want to do a classifier, but again, okay, so we want to look at a chunk of, let's say, one of the columns, chunk of data, and then you want to classify as, let's say, high liquidity versus low, right?
That's right.
Right.
So the idea I had in mind, so I listened to, as you know, I listen to a lot of stuff, and I've been listening to a very interesting book called Against the Gods, which is basically a kind of a modern history of economics. And they scream at you in the book that the future is not a function of the past, right? This idea that we can predict the future based on past events in economics is absolute. Like maybe sometimes, maybe not.
It feels like there's a lot of but it feels like there are a lot of caveats, right? Like I can probably predict the next 5 minutes with almost 100% accuracy on any dimension you ask me to, right? I can predict I'm probably going to be sitting here for the next 5 minutes, and it's most of the time will be correct, right?
I know, but when your only belief is that things will go back to normal, right? Things will come back down that went up.
Yeah, but I mean,
no.
In fairness, most of the time they do, right? So it's still like a fair assumption if you're like making decisions about this investments, right? Otherwise, everybody.
I know, but they just really hammer that home, because I think many people just, pray to the statistics and don't understand that, just blindly looking at the past isn't isn't enough.
Yeah, I get it.
So here's my suggestion for how we could detect liquidity. So when you have what's called so in financial terms, new information or entropy is called volatility. It's the same thing, right? So when a new piece of information arrives, there is this kind of perturbation which perturbs the system, and then it returns back to equilibrium again.
Right.
So here's my conjecture. A stock, so I'd explain the concept of depth, right? The depth just means that if the price moves a little bit, there's buyers and sellers available outside of the current price, right? And there's many, many scams that work this way, where they create high volume at a very, very specific price, and then they nudge it, even though there's nothing there, because they're trying to get rid of their stock, or they're trying to buy the stock cheap. And so they manipulate the market to create this situation where it appears that new information. So my conjecture in a nutshell is that the speed at which the volatility returns to equilibrium is a measure of the liquidity of the stock. So if it returns to equilibrium very, very quickly, then there's plenty of depth and there's plenty of kind of support for that stock. And so if it does move, there'll be plenty of buyers and plenty of sellers.
Isn't volatility like?
It's entropy. It's literally just a new piece of information comes into the system, it diffuses through the system. So somebody will find out about it and act on it. And then based on their action, there's this principle called the Baldwin effect. Have you heard of the Baldwin effect?
No.
So the idea of the Baldwin effect is that you can't escape copiers. If you do something that stands out from the crowd, it's a mathematical guarantee that others won't be able to potentially do as well as you, but they will do very close to you. And the longer the time goes by, the more that will become a bell curve.
Okay.
So that Baldwin effect, this idea that if somebody makes a lot of money, there's so many people watching that they'll just copy the person who made money and you'll get a bell curve, even though there'll be a spike.
So the volatility, if you wanted to read it off your data, would it just be a sudden increase or decrease in price, like beyond the threshold? Would you call that volatility? Is that the only way you can, I guess, directly measure volatility, because you don't know?
So the underlying model, as I understand it, is that a new piece of information becomes available to one agent, like one person sees something, or a handful of people see it.
Yeah.
And then they either report the information directly or they act on the information. And I would argue there's no difference, because as many people are studying your behavior as what it is that you're looking at. So yeah, so there's the initial thing. There's a small group of people whose beliefs have changed, who we can identify.
Yeah.
That then propagates very quickly, right? In the case of high-speed trading, that might be milliseconds, right? That information disperses to a set of buyers who have huge amounts of liquidity and will essentially want to move the market to the new equilibrium as quickly as possible. And so they will buy or sell, or whatever it is that they do, to bring the system back to status quo. And if it's some kind of crappy little stock with 8 shares and some guy called Joe sells a share, and then Jane looks in the paper on the weekend and says, oh, I think I might buy that share that John's selling, that's very, very low dispersion, right? Nobody cares, nobody's interested, it's not salient. So that has very low liquidity. Nobody gives a shit. So can we distinguish these two in a data set at any time scale, let alone this very long time scale? Because I would argue that all the effects I'm talking about happen within a day, and this is daily data. So
Yeah, I mean, just to test out your hypothesis, I guess it's easy enough to do, right? Like just, you don't even need machine learning. So you can probably look at like even Fourier transform of the data, right? Like if it's regularly sampled. So you're basically saying that if a price goes, suddenly jumps up or down and then stabilizes to
New
another,
equilibrium.
could be new, it could be the same equilibrium. You want to know the time scale of that event, and based on that, classify whether it's high liquidity or low. So
That's my conjecture, right? And
yeah,
we
yeah.
could
So I
probably
mean,
publish on this. Yeah.
so we can probably just do some kind of signal processing to do that, right? You want
I
to know
agree.
to just try it and then see, or maybe you can use signal processing to get a measure of that event and then use that as input into a classifier. See if we can do it.
Exactly right. Yes, you've got it in one. So you guessed everything. Good. Okay, so that's roughly what I was thinking. Okay, so I was going to do wavelets. I have another sheet which has wavelets in it. I'll just drop it into GitHub now.
Mm-hmm.
I think it's called Arima. Yeah, Arima. Is that it? One sec, sorry. If I go to my notebooks, and go to Arima. Yeah, so this is my geometric random. I'll just post this very file in the Git so you can get it.
Mm-hmm.
So one sec.
Yeah, I think the next step would be to probably that time scale should be normalized to something. Like if it's maybe a very expensive stock, it might be different. Time scale might mean different with respect to volatility compared to if it's a small one, right? So in your example of like Joe's stock, so maybe a weekly change is actually highly volatile. Maybe it hasn't been changing for years, and suddenly last weekend it was a blip. Maybe that means high volatility because it's a small number of shares. But then for Apple, maybe you need a much larger jump to know that there is something happening.
I agree with you. Yes.
So I think at that point, then the game would be to what other features you want to add in addition to your blip feature to get a better classifier. And then you just keep going with that game, I guess.
I'm just adding it to GitHub so that you can see it too. Okay, so you've got this as well. So this is based on, I mean, I can marry these together in 5 minutes and put that data set in. I just generated fake data just to, once again, I'm just trying to get stuff that doesn't crash.
Yeah, yeah.
So, yeah, so I just added a new thing there. So this is the Arima test. And the cool thing here is I've got a data generator. So this is standard code to generate a random walk.
Okay.
So, and then we can fit Arima to that and we get a bunch of results, which are interesting. But down the bottom here, I also created a wavelet filter. Not saying I know fully how to interpret what this tells me, but this is the kind of thing that you get out of it, which is kind of interesting. So this is the low frequency noise going all the way up to the high frequency noise. So given that this kind of spectrum is available to us, how would you suggest we could detect the return to equilibrium?
Yeah, I need to think about what I guess multi-scale helps you.
Maybe it doesn't. I don't know. Maybe it's impulse response, right? I really.
Well, I guess that goes back to what is the time scale we think is relevant for detecting liquidity, right? So maybe we want that particular scale. And if you have all these different scales, maybe it could help us to figure out which scale is the one we want. So maybe at least as a way to just explore the data set and see. Yeah, my problem with the data set is just, I don't know if you know it, but if you're just looking at the data, can you just immediately know what's high liquidity, what's low? Because I feel like we don't have the target. So it's really hard to do anything without knowing what the liquidity actually should be. Because I don't have enough domain knowledge. I guess Rob said he can look at it and guess what it is, but I have no idea.
Well, that's why I don't know either. But what I was kind of listening to my intuition. I was trying to decode how I would think about it, and that's where I came up with this idea that perhaps a good measure of liquidity is just the speed of decay of new information, right? If the rate of information diffusion is extremely high, and the market restabilizes very quickly, then
but here is the, I guess, well, you might be right, I don't know, but I'm just trying to think, because I thought, so let's say there is a jump, a blip in the stock price, and people want, like, the information spreads and people want to basically take action to resolve that far from equilibrium state. But the problem is, if liquidity is low, then they can't. So that's the whole point, right? People have the information, but they can't use it to.
Yeah, so I'm assuming that the information is basically not instantaneous, but really fast.
Right.
Like, it's not zero, but it's, within 24 hours. It's very, you'd have to be a pretty sad stockbroker not to check in each day how the market's doing.
Yeah, but I guess isn't the problem that we're trying to solve is, like, once you have the information, so if maybe I don't understand liquidity well enough, because I thought to the extent that
you've got it in one. If you've got stock that now sucks and you can't sell it, there's no liquidity, there's no depth, there's no one wants to buy it, right? There's not this pent-up demand and this pent-up kind of supply, right?
Right.
So there's this really narrow band in which people will buy and sell, and as soon as it goes outside of that, nobody's interested.
Yeah, so I'm worried that this, if you detect this jump and return to equilibrium, you're already past the usefulness of that information because it's already been resolved. You can't act on it anymore.
No, we're not trying to act on the information. Okay, that's the second part of it. So we're not trying to act on the information. What we're trying to do is to profile the liquidity of each stock, right?
Okay, so you want to know in retrospect, was that high liquidity or
like
low?
Is Apple's liquidity improving or diminishing?
Right. Okay, that makes sense then.
Okay, so I'm glad that it makes sense, because it might not. I don't know. So
yeah, I don't know.
Very humble here. I could be talking out my ass here. So just
no, but it makes more sense now. So yeah.
Okay, yeah. So I'm not trying to predict liquidity events. I'm not. I don't think we can actually do that. But we can predict depth, I think. Like, we can predict that a bunch of people are out there. There's pent-up supply and demand available for this stock. Right.
But can't you just read that off of the, like, if you're like, I don't know, do they provide this data in the stock exchanges of how many people are trying to buy Apple stock right now?
Very little. No, it's actually hidden information.
Okay.
Yeah. So that's what we're trying to infer. And it's also BS information. Because I can put a bunch of buy orders out there, and as soon as the stock price rises 1 cent, I can take them all in again, right? It's all bullshit, right? Everyone's playing games. So just
yeah, fair enough.
Okay.
Yeah.
They're all gardening and farming and doing all this psychological BS to try and trick you into buying something you shouldn't.
Yeah.
As expected. But generally speaking, I would argue that if we can see that the return to equilibrium is very rapid and very consistent, then we could argue that this is a high liquidity stock. And if that pattern, if that return to normal is slowing down, it means that the liquidity of the stock is diminishing. One would predict.
And of course, it's going to become super, like, if you go down to your plot you're showing now, like the one that you generated. Yeah, so let's say we get something like that exactly. Let's say this is the real one. Like, I am guessing most of the stocks is just going to be like slowly varying up and down. So which one of these you want to sort of identify as an event? Like, is the second peak near the end? Is that the kind of thing we want to see?
It's a good question. And it's a good question. I don't know. So the way I would do it is I would build rather than a random walk generator, I would build an information generator or an entropy generator that generates pulses of entropy in some synthetic data set. And we essentially simulate high liquidity and low liquidity and see what it looks like. Because information is coming in all the time.
Sure.
So we might not be able to build the encoder, but we might be able to build the generator, if that makes sense.
Yeah, so but I guess my point is that you can generate things that you would want to call high or low liquidity, but looking at the real data, I guess the question is how close to the ideal case that you're generating is. Like, is
so
it
this is
enough?
where we get into GANs. My suggestion, once again, this is all highly speculative, so I could be completely off here. So if we can build a generator, we can train an encoder. In other words, if we can build something that will synthetically generate a piece of information and then disperse it through the market at some rate, according to some underlying model of liquidity or depth, then my argument is that we could train an encoder on the synthetic data, which we can know what it means to decode it. And when the encoder gets good enough in the GAN cycle to be able to not be able to distinguish real versus the synthetic, then it's a good encoder. So typically with the GAN cycle, you start off with the data, and or you start off, with the data and a standard encoder decoder, both of which are neural networks. But in reading about it and studying it, I found that typically the mechanics of the encoder are completely different to the decoder. Like the generator in DALI is not the same, not kind of the inverse of the encoder.
DALI doesn't use GANs.
No, that's what I'm saying. It's diffusion, right? Yeah.
Yeah.
So I'm just, But so the GANs I've been looking at. So I did read that paper that you suggested on time series GANs.
Mm-hmm.
Did you have a look at that?
No, I haven't done any much.
No, that's fine. That's fine. So they have caveat after caveat after caveat, exploding gradients, vanishing gradients, all sorts of problems. So it sounds like the kind of horse whisperer thing, where if you're lucky, you'll get a result. But if you're unlucky, you can search your whole life and find absolutely nothing.
Mm-hmm.
I've had plenty of the latter and not much of the former.
Yeah, it's a difficult problem. Yeah, I'm not surprised.
But there is something called a time convolutional network. Have you looked at time convolutional networks?
I've heard of them. Yeah, I mean, it's obvious from the title. You just do convolution in the time dimension, not the spatial.
And
dimension.
they also do the trick, which is in, well, they reuse the trick in what are called skip networks, where you have the encoder, but you also pass the input and mix it with the output so that you don't lose information as it goes through the.
Yeah.
So it uses that skip network concept, but and the other thing it does is that it, in order to get long memory, it essentially takes the output of a neuron from the past and maps it many steps into the future. So it doesn't just skip one step, it skips 8, right?
Yeah.
And that way you can see the past from the future, right? You can see the distant past from the now. Yeah. I mean, if that's sort of the direction you want to go, I think transformers are also worth looking at, right? So I agree with you, and I went through several tutorials, and I actually wrote from scratch a transformer to try and understand it. And can I give you my understanding of transformers, or do you want to share your understanding with transformers before I give you my interpretation?
You go ahead. Yeah, I haven't looked at them in a while. I know very high level, but I haven't implemented them. But I know.
So my understanding of transformers simply is that the current set of beliefs are passed along as well as the data. So you're mixing past beliefs with new information, right? So you have this attention, if you will. So your attention is what you remember about the past, right? So up until this point, I've been at this altitude, and that's not quite it. So if I have a sentence saying the cat sat on the mat, then the transformer will know that there was a cat and a mat, and there was a verb sit or sat, and it will encode that into the attention vector. And then if I say the word mat, then the fact that I've said the word mat will be remembered in the attention vector, so I won't say the word mat again. So essentially it's like a checklist, a kind of statistical checklist. And if I've met all the conditions of the attention, if I've reproduced all the concepts that were in the original statement in the new language, then I'm done and I can stop decoding. Something like that is how I interpret
Okay.
it.
I mean, that might be true. I mean, yeah, I don't think of it that way, I guess.
How do you think of it? Sorry, go ahead.
I mean, I don't have much experience in NLP, so I don't think of it in terms of language, even though that's where it started. Like to me, it's very simple. It's like a mapping from a bunch of, let's say, 100 time steps into the past into the next time step. And basically all you learn is these weight vectors between all of those time points and the current time points, and which one of them had the most effect on what you will get. And you will learn that mapping, and you can go as deep as you want, and all it is just a matrix of weights. That's it. There's no.
I know, but the matrix of weights is available to you as information that you can draw on in your weight.
Yeah, so those are, I guess if you want to create a story around it, but it's a bunch of numbers that weighing what's sort of going from one place. I try to stay away from words like belief and entropy.
Okay, sorry, I can't help it. That's how I think. But yeah,
they just confuse me. But yeah, so in that sense, I think the translation is probably the best place to understand it. I guess going back to the language, when you have something in English, you want to translate it to French, you would get the weighting between the words in the English and the words in French. So you will know the positions of how you change the positions in the English grammar to the positions in the French grammar. So you will understand how you should swap different things and then translate it to make it French, as opposed to.
There's more to it than that. I think, in my understanding at least, is that it has this idea of memory. If you've already said the word cat, you don't need to say it again. It doesn't say cat, cat, cat sat on the mat, 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 mat. It says cat sat on the mat. So it has to know that it said cat.
Well, it's sequentially generated, right? So
that's my point, right? So yeah, as the sequence unfolds, it has to know where it is in the sequence. What concepts are left to be expressed here? Like if the word order is flipped, the output sequence is different to the input sequence. So we have to be able to know what we've ticked off, as it were, in the checklist, maybe.
Yeah, but I don't know if I would call it as like a memory, as in a human memory of use. I said that, so I won't say it again. It's just the input used to be the first 10 words. Now you set the math at the end. So now you recalibrate to the next first 10 words.
Idea. Yes. Yeah,
and then you want to see what comes after math. And usually math doesn't come after math, so you don't get it. So it's like
I see. Okay, fair enough. Okay, that's a good way of thinking about it.
Statistical thing, right? Like whatever you have now, so whatever is generated is conditioned on what you have, as you said, what you can call it memory if you want, but it's like your input. And if math is already included in the input, there's no reason to add it again.
Which is missing from convolutional neural networks and from just standard, multi-layer perceptrons, right? They don't do this.
But just a totally different, I guess, problem. I mean, you could do it, right? It's just, yeah, I guess in transformers, there is fewer, I guess, inductive bias as you like in convolution, you're putting in the translational invariance. Transformer doesn't care about it. If you give it enough data, it learns if you need translational variance or you don't.
That's right. So how could we map this idea of transformers onto this application area, do you think? Is there an application for transformers here? Could we detect information dispersion or liquidity, like this volatility stuff with a transformer? I think you could.
Yeah, probably could. I don't know what's the best way of doing it right away.
No, okay. Anyway, that's where I was going with this stuff. I'm curious where you would have gone, or where you think I should go, or what do you think? I mean, I'm just pulling out what I know, but I'm very open to suggestion.
Yeah, I think for me, I need to understand liquidity more, and yeah, because I don't know, I've never worked on I've never worked on a problem where the target variable is not known. So you are trying to do two things. First, you want to basically, you need a parameter or a feature that captures liquidity somehow, if a value, but we don't have that in the data set. So the first job is to create that, and then you want to detect it. So when the detection can be done with machine learning, or at least supervised learning, right? If you have, let's say you had a column of liquidities, then it's a very easy problem, right? You just train it and you see how well you do, but we don't have it. So liquidity to me is like this vague concept that nobody understands, and nobody can put a number to it. So it's hard for me to know what is the best way of.
Yeah, so
predicting.
the other approach I was considering, which I think is dumb, but it would work, is that you give me a single or a very tiny set of examples, right? So a tiny amount of labeled data, and then we use that to generate an SVM, and then we use that as our classifier. Okay, so Rob looks at the data and says, here's 5 liquidity events. Okay, and then we could use those as the support vectors in some sort of a classifier, and that would give us a very kind of simple, naive, but explainable liquidity. I'm not keen on it. I'd rather use the kind of information dispersion, volatility stuff, but might work.
Yeah, I mean, there's, I guess, multiple ways of looking at it. Yeah, I guess I feel like Rob needs to at least provide me with more understanding of what liquidity is. I guess you guys have been talking about it.
This is my interpretation, once again. Yeah.
Because if you can do that, I mean, there's other ways. Like if you just care about the results, like you can use fuzzy logic if you want, right? Like Rob tells me, how do you look at this graph and tell me it's high liquidity? And he says, okay, if the slope goes beyond this and stays there for 2 days, then I call this high liquidity. Then you can encode that in your classifier and just look for it, right? It's like it's not very exciting, but you can do it.
Yeah, it's not very thrilling. That would work. Yes, indeed. Okay, very good. All right. So that's all I've got. That's all I did. I think I'm very interested in this autoencoder stuff. So I'll just kind of give you some ideas as to what I was thinking of, where I was thinking of going with this, just to see what your thoughts are. Once again, I'm just making this stuff up, so I could be completely wrong. So at this point here, we actually have the latent vector.
Yep.
Right, we've got it. Okay. So what's going on in computer graphics land is that they are going encode, and then they're going, right, they're going, oh, Z prime is equal to some function of X, and they're futzing around with the latent space, and they're doing all this crazy shit. Sure. And then they pass that into the decoder, and you've got the GAN style of a generative model.
Yep.
Have you ever done anything like that?
Yeah, so that would be basically like, I don't think you can do it with this version of the encoder. You have to do the variational encoder, because this is not a generative model. All you get is a number. You're not going to get a function out of it. It's just going to be a string of numbers, right? Right,
but I can manipulate those numbers, or I could record that number somewhere and then put a whole bunch of data into the input. I'm not using it to train anything. I'm just trying to characterize the encoder. And then
you can use it as you can try. I don't think it will work, but you can try it as so let's say you had a time series that were 100 points, and then you get to this latent dimension, which is 5 points, then you can use that to classify, right? Because that sort of condenses, but that doesn't work. It definitely doesn't work in case of the encoder. You can try, because oftentimes what's needed to determine what you need for a classification is not what's the same thing as what's needed to reconstruct the input. So you will lose. So if you're going to do this, so basically if you create a classifier, a binary classifier, that's what it's trying to do, right? It gets a latent vector, and then it classifies it. And then because you are using the labels to guide the encoder, then you will get a latent dimension that actually makes sense. Here it could be anything, right? There could be infinite number of ways to condense your input into something that can be decoded. But
I was suspicious of that, yeah.
Yeah, but those features aren't enough to distinguish between classes that you care about, because you didn't know that when you were training the encoder.
I agree. I'm just curious as to, so here's my naive understanding once again. If I take the latent vector and I do that and I encode a bunch of different data on the input, and I just store the Z's. I'm not decoding anything. I'm just encoding this chunk of time series data into this latent vector.
Yeah.
And then can I take that and do principal component analysis on it? Can I try and manipulate by small increments each of the dimensions of the latent vector to see how it's affecting the output? Can I try and use manipulation of the latent vector to allow me to gain an intuition of what the encoder, what the decoder is doing, and thereby what the encoder is doing? Do you think that's a useful line of inquiry, or is this ridiculous?
I don't think it's ridiculous. I just think it won't work for the case of the encoder. So if you want to do that kind of thing, you can do it, but then you want to use a variational autoencoder. So in terms of the variational autoencoder, the Z that you get, the components in the Z are not just numbers, they are mu and sigma of distributions. So then you can use it to interpolate or sample from it again.
Okay, so if I change this, would a VAE work in an unsupervised setting?
Yeah, VAE is also like a GAN, right? It's unsupervised. So it does the same thing, except instead of just having a bottleneck that's an array, it generates the array that are just distribution points. So its problem is that it's assumes Gaussian distribution for each point, which is not accurate. So you will lose some information there, but it's a generative model. So you can use it to interpolate and generate output and see if you want to do this manipulating the latent vector and see what happens in the output. That's what you would need.
Got it. Okay, I'll switch this to a VAE and we'll play with that.
Yeah, that should work. Yeah, and I don't know what you would get if you do PCA on the latent space. I'm not sure what that means. I've never heard of it.
Once again, this is my naive understanding where I'm trying to map all these concepts into philosophy, and I'm not sure that's a valid thing to do. So,
I mean, it's almost like doing, it feels to me it's redundant, right? Like getting the latent function is kind of doing a PCA already, and it's non-linear. Why do you want to do another PCA on top of it? You are reducing.
Okay, so let me explain what I mean by PCA. Okay, if this parameter here, if I vary it by 0.1, how much variation do I see in the output? None at all. Okay, that's not significant. Okay, if I change this parameter by 0.1, I see a huge change in the output. Oh, okay, so there's a sensitivity between the value of this parameter and the output, right? So I can essentially rate each parameter's impact by essentially changing it and seeing how different the output is based on the changes in the latent vector.
And how would you quantify the difference? And what do you mean by how different?
So it would be probably KL divergence between the two generated outputs. So I have Z and Z prime, where Z prime I've made a small modification to the latent vector. I pass them both through the decoder, and then I do a KL divergence on the output of the decoder, and the one with the highest KL divergence is the one with the highest sensitivity.
Okay, I mean, yeah, we can try it. I mean, first of all, I mean, if you've done a good job of encoding it, right? If it's Z is a small enough vector that encodes the thing, you should probably see there shouldn't be any variables that doesn't create a huge difference in the output, because it's supposed to be compressed.
That's an interesting experiment, right? Because if there's only 5 principal things that actually have any effect and all the others are just encoding noise, maybe only 5 of them are relevant.
Yeah, so then you can probably reduce your bottleneck to 5 in the
right. But if they're all super variant, then we should probably increase the size of the latent vector, because there's more than 128 parameters in play. So this is a kind of a way of crudely kind of sizing the latent vector to see. So these are valid strategies. Okay, cool.
Yeah, I mean, you have already got it coded up and trained, I guess, so you might as well try it. I mean, when I tried it a few years ago, I didn't get any useful information out of the latent dimension in an encoder. So you will probably, my prediction is when you start like playing around varying the different Zs, the output is just going to be changing in random ways that you would not be able to get anything useful out of.
Even if I made the changes minute, like 0.0001.
No, then you would just get it slightly noisier. I mean, it won't make a difference, but it won't correlate with like anything tangible that you can say, oh, this
so we can't forge intuitions by manipulating these.
That's my guess. Yeah.
Okay, so that's true, and that's what's been found in the lit that I've read. And so what they then do is they then train they train models that that are parameterized with parameterized that you do understand. And they fix the GAN output and they retrain that as an encoder so that it will encode the variables that you want. It'll create a mapping from your input variables that you care about to the latent space, and then you can reuse the generator to generate the output.
Yeah, I mean, that's fair. Yeah, if you want to do that, yeah, you can do that. If you know, I guess, what you want. Yeah, it's oftentimes it's hard, at least for images, it's hard to specify exactly what you want, right?
So I have this economics model called the standard theory of economics, and I want to see if the data that's output, if there is a coherent and consistent mapping between standard economic theory and the generator that I trained on the bazillion stock trades.
Okay.
And if there's a high correlation, that means that the theory is a good one. If there's low correlation, then perhaps the economic theory is not very good.
Okay.
That's the kind of intuition. Like, let's take the quantum gravity thing, for example. Like, nobody knows what quantum gravity is. It's the same kind of thing as liquidity. We can't really put our finger on it. You know, it's kind of weird. Can we train a model on a bajillion petabytes of data from the Large Hadron Collider, train a GAN that can reproduce that model, and then try and map the standard model into that generator to see if, when I change gravity, I get the appropriate changes on the output that I would expect, and it's coherent and consistent. And if it isn't, then perhaps the standard model from.
Yeah, I mean, so that's a good example, because I think it's similar in more than the way you mentioned. It's so all the data that they have from the all the historical experimental data is consistent with the standard model, but we know it would fail at some point in let's say inside of a black hole. So how would you go about figuring that out? Because you will never have the liquidity or the number that's associated with that. So you're trying to create a theory for something that you're not measuring it directly. So it's like a double challenge, right? Like there's probably infinite number of theories you can generate that come up with alternatives that are, at least right now, not testable. So then you just keep publishing papers and talking about it, but it's not testable.
The GPT-3 of scientific papers, where you just hit return and generate a new scientific paper all day. That'd be fun. Kind of make the academics a bit sad, but anyway, that's fine.
But yeah, anyways, I mean, I would try variational autoencoder probably before trying the fancier things you talked about.
Sure, I'm just throwing this stuff out there so that you shoot the stupid ideas very quickly. So I'm very happy for you to do that. So
no, I did my first project at MDA. I did exactly what you did. So they had a bunch of satellite imagery. They wanted to, these are like SAR imagery, synthetic aperture radar. So they look like black and white, like intensity maps. So and they wanted to classify different ships. And so some of it was labeled, like a small subset, but most of it wasn't labeled and nobody wanted to label them. So my genius idea, also similar to yours, was that, okay, why don't we train an autoencoder, and then it's much easier to classify those. It totally didn't. I mean, some of them it got right, but overall it didn't work. So I'm sure you get something out of it, but it just, I guess it's a question of how well it works. But yeah, I mean, if it worked, it would be like, I think it would solve lots of other interesting problems if you could just train an autoencoder in an unsupervised way, and then the latent vector was useful for something else. I think that's the fundamental paper in information theory that would get lots of people excited. Because I think there's a theorem for it. I don't remember what it is, that the encoding depends on the task. There is no universal good encoding that captures everything you might want to know in the future about your input. So depending on what classification you want to do downstream, you would need different types of encoding. So you can't just separate out the two operations linearly, do encoding, and then do whatever else you want. So that's sort of at least that's the common wisdom. It might end up being incorrect, like I hope so. That would be very exciting if there is an optimum encoding that captures all the important features for things you want now and in the future. I think that would be awesome, but I don't think such a thing exists.
Interesting. Very good. Okay. That's it for me. I will switch to a VAE exactly as you suggest. And do you mind if I put the occasional ping in Slack? I really keep that channel very quiet. I know you're a busy guy.
Not at all. Yeah, no, yeah. I'll keep an eye on it. Sounds good.
Okay, I have another very different question. So I just came back from my holiday in Europe, and now I'm heading off to Australia to spend some time with my family there.
Cool.
But what I don't have right now is employment of any kind. I'm actually kind of floating along. What would you suggest? We're thinking of setting up a consulting company or something like that, just to bring in a little bit. We don't need a huge amount of income. Like I don't need to like slog away for 50 years to pay up a mortgage. I'm past all that. I just want to get some income rolling. I'm just curious what you would do in my situation. How would you approach it? Should I just go for real jobs or?
Yeah, it's hard to say. I mean, if I could make it work the way you've been making it work by doing like consulting, like picking your project, I would love to do it, right? But as you see, like it's not sort of, you can't guarantee.
And those projects are rolling along. It's just they're sporadically funded. And I have a huge network and all that other stuff. So I was thinking of just firing up a consulting thing and then just approaching local businesses to see if they need consulting services, something like that. But
yeah, I think that's hard. I mean, the best way is to somehow set it up so people come to you. That's usually the best way. Because if you go cold call, like I haven't had much, I tried as well. Like I haven't had much luck trying to chase after people. Yeah, I don't know. It's tough. I've never done it. If you figure it out, let me know. I want to try it too. I'm happy to partner with you if you want to do like something that you think I can help out with.
really? Oh, okay, great. Okay.
I have it in my LinkedIn that I take consulting jobs once in a while, but usually what I've been getting is either like some very tedious thing they want something to do, somebody to do, or it's none of it has been interesting enough for me to be worth doing.
Okay. All right, well, let me take that then. No, I was just curious what you would say, but the fact that you're interested in collaborating is very exciting. So that's great. Okay.
Yeah, you might also want to chat with Robin because he has his own consulting business and he's had clients. So he might be able to tell you.
Sure, I might give him a call and just have a chat about that as well. Very good.
Yeah.
Cool, man. All right, well, thank you for your time. That was a lot of fun. And I'll work on the VAE. And as I say, if you don't mind, I'll occasionally just post a little comment in Slack every now and then. And if you have some time, I'd love to follow up.
For sure. And then I guess once you go to Australia, you mentioned that we need to change the time. I guess we'll figure it out when you go there.
Yeah, we'll have to move it to later in the day. I still want to keep going. There's no stopping. I've got nothing else to do there. So I want something to kind of chip away at. So this stuff's perfect. So.
Okay. All right.
Very cool. All right. Thanks, man. Okay. Take care. Bye.